Hello everyone, welcome to Try Rides, the new era of learning. Myself Rafiq. So let's move to the topic. Today's our topic is a support vector machine (SVM). It's a concept in machine learning. Okay. So what is support vector machine? Support vector machine is a defined as a machine learning algorithm that uses supervised learning models. So complex classification, regressions, and outer layer directions problems detection problems by performing optimal data transformation that determines boundaries between data points based on the predefined classes, labels, or outputs. Okay, it works by finding the optimal hyperplane and the best separate different class in n-dimensional space. Okay, so SVM usually particularly affects on the high dimensional spaces, and it widely used application like image recognition, bioinformatics, and text classification. So in simple terms, we can say that support vector machine is a supervised machine algorithm used for classifications and regression problems. Okay, but mostly it used for classifications only. Okay, so in simple words, let imagine you have two objects, two types of objects like apple and orange. Okay, scattered on a table. You want to draw a straight line, best separate them. Okay, uh, SVM find the perfect line on our boundaries which divides the two classes with the maximum gap margin in between those. Okay, that's called hyperplane. Hyperplane is nothing but this. So I've explained it deeply also for that. So hyperplane is nothing but it is a boundary that separates the different classes in two-dimensional, in a line, in three-dimensional, or a hyperplane, or in n-dimensional. So firstly, we explain about this classification, image classification and pattern recognition. So it identify the where the object is located. So for the first thing, single object is cat, identified cat. For multiple objects, we have the cat, dog, duck. So it identifies the both as a separate instant segmentations. Okay, object detections for boundaries by dividing the boundaries. So matrix for matrix also it uses. So I had an example. Let's take I had an example of iris flower. You all know about iris flower. It is one of the most kind flower in our nature. So it has a three species. The flower has three species like Iris setosa, Iris versicolor, and virginica. Okay, uh, there are three species of the Iris flower. So for that they are both same. Little bit difference in the color and okay. So one of the flower type, uh, if flower type leaf is called sepal. Okay, and the leaf type object like determine in simplified little bit leaf, it's called petal. We have petal and sepal of the species objects. Okay, so this is the so Iris species, three types of species. Okay, from this now I into introducing you. So is the we have a graph on petal width and petal length. Okay. So from this we have to identify the setosa and versicolor. Okay. For this flower, the setosa will be green and the versicolor is blue. Okay. Here we have two types of data. I am explaining the hyperplane. Okay. It is having two-dimensional diagram here. Okay. From these, the data will divide. Support vector machine classifies identifies the pattern and the structure. So divide the classifications. Okay, from this is one class one and this is class B. So in this line, the in petal length and sepal length, it divides the pattern like how many possible ways it can divide the classes. Okay, it divides the objects. I have single line, double line, and multi line. Where the perfect line where matches, that's a, support vector machine considers. Okay, we can draw parallelly uh, how many lines can we can. Okay, so from that the distance between the order which is the nearest distant line it will consider that. So you see here I have setosa and other one versicolor, right? So both are having which line consisted the similar distance between the both objects, the line will be considered. Okay, so let's see, the margin will drawn and the support vector machine is classifying the object how many nearby and distance and where the for data. And okay, like this support vector machine enhances the data. So in this data, we have on a tricky line like we called as high gamma and low gamma. High gamma is nothing but we have randomly data in graph. Okay, nothing but we are didn't locate a specific place. Okay, but the data will be presented randomly. So in this case we could not. So this is a diagram. In this case, we could not draw a diagram hyperplane. Okay, with a linear line. So in that cases, in like the similar cases, the line will bend. Okay, the line will bend and it cause the comfortable line. It draw a comfortable line so between the objects. Okay, for a better identification. Okay, here we can see in the diagram of the cat. So here see here are multiple objects, right? It determines a line in between the objects like this. See, the cat has reds and the dog has blue and duck has green. Like this, its outer layer will be declared. Okay, based on the objects. Okay, Haigama logo we can say C for that. Okay, and it is two-dimensional and it is three-dimensional. Okay, hyperplane. For that, it also exists in n-dimension, but n-dimension is still working on it. So we can classify also, we can think if the presence of n-dimensional also, in that case n-dimensional also, the vector support vector machine will works. Okay, and the support vector, the data points are closest. Okay, to see the data points for the closest to the hyperplane, and those points are most critical to define the hyperplane. That's why the name is support vector machine. Okay. In this margin, the margin is nothing but the distance between the hyperplane and the nearest support vector from the both classes. Okay. SVM support vector machine tries to minimize the margins to make the model more accurate and robust. Okay. Why we have a question why we use SVM? Okay, for works well for small to medium data sets, good for clear margins of separation objects, effective in high dimensional spaces, and we can say also can be used for non-linear data using kernel tricks. Okay, uh, we can say linear. What is the difference between the linear versus and non-linear SVM? So linear SVM nothing but when data is in linear separatable can be divided by a straight line. So we all know the linear regression. We can divide the data by drawing a straight line. So non-linear regression nothing when a data cannot be separated by a straight line SVM uses kernel function to translate the data into higher dimensional to make the separate like this. Here we see gamma like this we can separate the data. Okay, so in simple terms, it uses in example SPM uses for say, email detection, image classification, face recognition, sentiment analysis. Okay, so in simple terms, we can say it as SPM is like a smart robot that draw a line between two different types of data, such that the line is as far away as possible from the both types. This helps in clearly knowing what the belongs to what. Okay. Now we take has this is the data like we are discussing now. Random data where we cannot draw a straight line from the both. Okay, we cannot divide the data by straight line. Okay, for these cases, that the dimensional will be flipped. So we create another line Z. Okay, for the data is clearly moved. Okay, so this is the expression of the code. So let's create a model of SVM. First, we need to import the iris. So it is don't worry, the iris flower will be data will auto is installed already present in the model. Okay, in sklearn. So for that, first we need to import pandas for reading the data frame. Wait, what happened? Okay, imports pandas as PD, and after that from sklearn we know from sklearn dot data sets. From datasets, we need to import iris. Sorry, load iris. Load iris. Okay, from this we take the load iris. It is the flower. It already in scale and we the data will present. So from iris, this is the iris. We import the iris. Okay. Now, what we can observe the what the data inside the iris load iris. Okay. For that we all know dictionary DRI. I want to know what object, what types is in the iris. So has a data modules, feature names, file name, framework, and sorry, frame, the target name. So in that, I want to know future names of iris. Okay. From that, I want to know the future name of iris. What are the species of iris? So for that, I specified iris dot file names. So it will say We had a sepal length, sepal width. We know the sepal is nothing but a flower object, and petal is a leaf object. Okay, we have explained in previous image. So we have the both. We want to consider the for sepal and for petal. We have plot the different maps. Okay, to clarify the structure. So from these, what are the targeted names? Let's see the targeted names. So we can see the target. So we can see the three species of the iris: Setosa, versicolor, and virginica. Right. So from these, now we can see the data also. So how many what data is present in it? It may be in matrix form, right? Maybe present the matrix data 64 to 64. Okay, see the data. Here we have them in matrix form, the data like 5.1, 3.4, 1.7, 0.2, like that. This data we convert, we want to let us separate this data. Okay, we didn't clearly identifying the data, so let's separate the data. Okay. For this, we need to firstly mention the target for this. So we also see targets. This we want. I want to check the target. Okay, I have a target has 0, 1, 2, 3. So in previous class, I also explained about 0, 1, 2 is nothing but in decision tree I explained in company. Like in decision tree example, I explained that in company statements, if we have three items or three objects, it's considered like 0, 1. So the system will be understand the by a bit code. Okay, binary code it understands. Okay, for 0, 1. So it takes a 0, 1, 2 objects, right? Okay, 0, 1, 2. Okay, for 0 Setosa, for Virgin of like wait, sorry, okay. 0 for Setosa, versicolor for 1, and Virginica for 2. Like that it consider. So from that, we know we want to create a data frame. From this, we need to create a iris data frame, iris dot data. So I importing the data has CO columns equal to iris. Okay, future. I want to mention the future names also. So I considering future names too. Now we are separating the data. We want to present this both data, the target and data, this both data to into in a future names. So present in a night in a table format. Like we want to print that in table format. For that, I'm creating like this. So df data frame equal to. So now see the data frame object will high. So I take our maximum value as 5. So we see we have sepal length, sepal width, petal length, petal width. Now see the data here. We can see the data here. So it is 5.1, 3.5, 1.42. So it is not in proper format. Now it is in a table format. We can understand what is the sepal length width, what is the sepal width, petal length, petal width, right? Now we want to find the target. Okay, now we want to find the target. Okay, from the of target table, I'm assigning the target for it. Now I'm take the targets from targets iris dot target. Okay, now pf dot header. I'm entering the target column. I'm entering a new column, okay, for the table like say settle and sepal with petal and petal with. So I want a column. So I'm adding a column of target for the target. Here is target. Okay, see. So here we can check the column here 0 to 50. I think we have 150 data here. So 0 to 50 Setosa after that Verzenica like that we have the data. So here 0 to 50 we can see wait I will show you df 1 to 50. We can see 1 to 50 here we have 0, right? 1 to 50 we have 0 data. So from df line not like I will show like easily. So from 45 to I take 65 a little data of it. So half of the set of half of the this data. So see 0, 45 to the up to is considering 49 up to take 49 0 after that it's considering 1, right? Like that we can check again. From it take 90 I think. So from 95, so 105. I like check this. So see here we can see 2 1. So we have a estimation data here, right? So now I want to define the target like df. So I can see how many ones like this. I can see like this also. So I want entering the targets. Right, I'm entering the targets which are equal to 2. So I can see how many are equal to 2. They will present here. Okay, 2. What are the data of 0? I can check like this also instead of slicing. So now we can check the data here. Now I want to add a new column. I here I'm mentioning only sepal length and width. I didn't have names of the flower species. So I want to enter a new column for that. DFFLO. So here I entering the flower name, a new column for whom I am entering DF there to my equal to my DF target. Okay, from DF target dot apply lambda. Lambda is for dividing the by x and y. So target names which consider into x. Okay, lambda x iris dot target names for assigning x now. Okay, for here create. Now I want to print it. Now so something syntax invalid. Wait, I will check. So I'm assigning the flower name, right? Okay, flower name df dot target. I'm applying lambda function here. So okay, here lambda, not lambda again. Okay, lambda function here. So for x, write this. Okay, now it will set. Okay, okay, I send the values of x set also. Like we can see we can check the data here also. For we all know, we can check like same way. D of equal to 45 to like 55. We can see the names of uh, both data. See from the 45 to 65, it consider as Setosa, and from 50 to 50, 100, it's at Versica. After that, I can see the data of 55 to 105. Oh, no, it's longest number. From it takes 95 now, last number. So 95 to I take 105. So see here, Versica after Virginica from the 150. Okay. Now I want to draw the diagram like this. Okay. Let us show it. Like this, I want to draw the diagram. Like the data I want. Like this, I want to take a data. Okay. Like this, I want the data. For those data, I'm considering I want to create a data, like we want to create a variables from df1, df2, from data frame 0. For data frame 0, I'm considering two starting values, nothing, we didn't measure. So from starting, I want 50. Okay, from starting on 50, from df1. From df1, I'm taking the list from 50 to 100, and from df2, I'm taking 100 to end. Okay, 100 to end. Like this, I'm created data. So now I want to import that. Okay, by how we use matplotlib, right? Okay, now we want to import. So now for better clarification, I enter like this. Wait, for if anyone seeing the video, it's for better. So is enter data. So from this, I want to petal. So we all know in data frames from pandas, we all know how to design. pattern of the data by using X label and scatter plot designs in linear regressions. So right, the X label for the X label. First, we mention the data like this: X label and Y label. This is Y label. In X label, I'm entering the data call like Setosa. I'm entering the data Setosa or not Setosa. I want to enter the sepal length actually. I'm plotting the X label. So here I firstly okay, let be fine. Okay. Instead of mixing all, I take sepal length, sepal width separate and petal length, petal width separate. Okay, for the sepal length, I take firstly sepal length. Okay. Now take sepal length and after that take sepal width. Okay. I take the both data. Now I want to plot a scatter plot here. I take a function called as a scatter. Here I want to do the two x and y. So I take d of 0 and d of 1 from here. Okay. From here I take sepal length, sepal length, comma. So name of the over length over string. Okay. From here close. I want to close the list. And for this, and I taking same as to sepal width d of 0. Okay. Same I am taking same. So here I am considering sepal width. Like this sepal which I am considering from g of 0 I am considering in d of 0 data frame 0 here we created data frame right when it's gone we created data frame right for d of 0 I am considering d of 0 1 is sepal length and sepal width and after the same I create d of 1 sepal length and sepal width. Okay. Okay, now like we want to color right okay, let's take the function called color. So for color of sepal length I take here green. For color I green and for marker so I want to mark different like for marker I am taking for first one I take plus. Okay, for this I take plus. So same as down. So here also I taking same but I am changing the value of df1 here. Okay, df1 instead of this I take dot, it is better. Okay, now let's see the graph will shows. Let us wait. Or something might be wrong. We didn't mention length. Right. Okay, okay. Sorry. Didn't I consider I? Okay, okay. Now it will fine work fine. So now see the data. Oh, sorry for didn't mention the color here. So here I take any random color like blue. Now we can see clarity as well. So we have the data of see how the middle the data is declared confer if divided. Cluster. For same, I want to create petal also. So I'm copying this again. So I paste here again. So for this I want to create petal. So instead of this I want to create petal length here. So now I'm considering petal length, right? Petal length, petal width. Okay. Now I want to take the petal width. So it's I think it's fine now. So nothing where the error key length CM. Okay, for here I did a mistake, right? Okay, no, let's wait. I take this column too. I take whole column, each gap or any spelling mistake take as like this only. Like this petal length. No, it's okay. From here, petal width. No, see. Again. Okay. Wait. Here I have double column. Okay, now it's right. Now it's right. See the data, how it divides the data. Like that, we can see divide the data, our data. So now I want to train my model like this. I will create the data. Now from that, I want to train my data for DF. Firstly I want to drop the target names, right? I didn't need this. So target and floor. First I drop these names and I assign to the Y. Okay. So for that, what we need to drop from what you're dropping target. I'm dropping target and flower names, right? Target and flower name. I want to drop it. So by axis, right? Axis of columns. Okay, I think it's done. So now what I do? Okay, I didn't assign it to Y. Okay, right? For I assign this Y, and for Y I am assigning the D of target again. Now we can have created successfully. Now from sklearn we want to import a model from sklearn model selection. We need to import the we all know train test split model. Train test, it is necessary in each and every algorithm to train the model like this only in machine learning. We want to try and check the models of the test values. Okay, train test split. We import this, copying the data, and now I want to give the test like that for it. Okay, I want to see the data, right? First, train x train x test y train y test. I want to assign these all to test plot split. Okay, train test split, and here I want to give the values for x and y and test size, right? And test size doing has up to 0.2 has 20%. 20% I'm trying that. In K-fold, I've explained the why we take 20%, 30%. Okay. Instead of 20% nothing, but we train the model. So like that, the data will take first 80% for train, 20% for test. After that, we take 40% like that. The data will step by step for and coming down. Like after that, the first part of the data 20%, which is assigned to the tester. After that, it converts into train, and after that, the below data, the again the forward data to 20 to 30, 30 to 40% where the data will already train. That's into the test. Like that, the 20% it divides the data into five parts. Okay. From 20 data, I'm testing like that. So okay, now it finished. Now I want to check the what the length of the X test. Okay. Now I see 30. And I want to see the length of the extrine. Extrine it's for 120. Now, what is the actual length of X I want to need? I can almost I see almost we had a 150 data, right? You can see the 150 data here. So now here we can create a proper model here is sklearn dot svm import svm svc support vector classification, right? From svm we're importing support vector classification. I want to see in capital. Okay. From that I'm creating a model equal to svc here, and after that I want to fit that model. I want to train those model for x train and for y train, right? From right end. So see how my model. Okay, successfully my model was created. I want to check the score of my model. Model dot score for how much for x test and how much for y test. Wow, I get 100% score here. So okay, like that we can create the model on the using the data set like this. Okay, it is data set. This is the how to identify the two object classification, and we can create the model and we check the score of the sepal of the iris flower. So here we take the flower as an object, and these we consider the three species. For these three species, we take sepal length and sepal width, and both sepal we do sepal length and sepal width, and for petal also we do petal length and petal width. So how the data is divided like that. Okay, so okay guys, I hope you guys all understood. Thank you.